Okay, I think we can start. So it's great to see you. Actually, I think I've never spoken in Wrocław. I think at least on a JAG. There was one on conference too, but it's my first time on the JAG. So it's great to see you all here. So today, as we can see, this is a special event because there's a couple of us Hazelcast folks over here. We are on a tiny tour. So I thought I could set the stage for Favas and give you some interesting insights in what we've been planning with the product, what's been happening with the product for last years, and give you some ideas that we are actively working on, and some crazy bets we might consider doing in the future. So my name is Grzegorz Piwowarek. I'm a lead architect at Hazelcast. And in my bio, you can read that I exist mostly at compile time. But since I'm an architect and PowerPoint compiles rather most of the time, I end up existing also most of the time. So my first experience, my first exposure to Hazelcast was very long time ago, I think around 2014, 2015. I went over, or no, even earlier, I went to one conference, and I remember there were a couple of Hazelcast folks on the booth, and one of them stopped me and they were like, "Look, I will get you this really nice T-shirt if you tried our product out." And it was a basic IMAP, basic get and put like demo. At that point in time, I was young. I thought, 5 minutes for a T-shirt, that sounds like a good investment, like a good trade-off. So I wonder, and the tool worked pretty amazingly. So the demo I've been shown is pretty much they created a couple of instances of Hazelcast using just simple Java code. They started them, and suddenly they created a cluster and were able to do basic get and put operations. And that's what Hazelcast was for a very long period of time. It was a Java-centric cache. So we would compete, with Redis, with Coherence, or other tools like that. But to be fully candid, I worked with Hazelcast later on in my professional life, but it was only when I joined Hazelcast when I realized how much of stuff I've been missing. And my point for today is mostly to show you some parts you've been missing, and also give you ideas about some stuff that will happen in the future. So as you can see, the idea was fairly straightforward. On the bottom, you can see some data sources, mainframes, databases, REST services, NoSQL. On the top of the picture, you can see some rectangles and arrows which represent some services. And usually you would like to consider Hazelcast in the past where you want this additional layer of high availability and lower latency at the price of some consistency. But that's no longer the case. So that's no longer the case because now we became polyglot and we've started adopting way more interesting things, which I will get to closely. So from your point of view as a customer, as a user, you get multiple nodes working together, giving you an illusion that this is just one big map. But actually, behind the scenes, what's happening is that you have multiple members and your data is partitioned. So each member gets its own share of a deal, plus some redundancy for the sake of high availability. But at the end of the day, it's the client, smart client, and the cluster itself which is responsible for routing the requests to the right member and access the data. So members don't clone all the data. This is not a replicated data structure. It's partitioned, at least when we are referring to the basic IMAP. And fast forward a couple of years, and things started getting interesting. At the beginning, Hazelcast was embedded only. which means it would just start as part of your JVM process. But as bigger clients got interested in that, there arose a need to have a client and server separation, which means that the Hazelcast wouldn't be running in your process, but somewhere else, and you would just use the client to connect to that. And once Hazelcast wasn't, and Java library that gets embedded in your application, it suddenly became possible to create more clients. So .NET, Node.js, C++, Go, there were some ideas of Rust as well. If you are working with any other languages or one of these, there are no issues connecting and working with Hazelcast on itself. And we stopped calling Hazelcast a cache. There was this idea of IMDG, in-memory data grid. So that might sound complicated, but if we try to break it down, in-memory means that data is actually stored in RAM memory. And the biggest advantage of keeping data in RAM memory versus on hard disk is the speed. Because between the RAM and hard drives, there is an order of magnitude difference in latencies. Obviously, when someone uses the term in memory, the emphasis is speed and lower latency. However, the recent development in hardware proved that the line actually gets a bit blurred. Data, as you can expect, that means effectively that you can store the data. But when we mean data, it's not about the storage. You can actually do something on the data. So it's not just a cache, but you can perform server-side computations based on that. So once you have your data populated, there are no problems changing it in a way that's optimal. And the optimal way of doing that is by letting server do the job. So quite a common misconception I've seen is that since if there is a map interface, if you want to change data, you would go and forage through all of that. And that's, as you can imagine, it will work for very small data sets. But if you suddenly if your cluster holds terabytes of data, suddenly for itching through all of them and then putting them back into a map doesn't sound feasible. It's the members that should do the job. That's why we are speaking about computational capabilities of Hazelcast, which get expanded even more and more, which you will see in the future. And grid, in the name, pretty much means that this is just a couple of, this is just a cluster. It's a couple of nodes working together, forming one system. And as you can see, it became fairly complex already, but complex by not from the usability point of view, but from the feature standpoint. But that's not all, because on the side we still had another project running called Hazelcast Jet. But we'll circle back to this in a second, because before we go further, we need to make a few notes. So normally, where would you put? So obviously, Hazelcast can be pretty much in. So if you go back over to this slide, Hazelcast is between, let's say, the database and your service. And it sounds like an easy job to actually write the logic that's responsible for putting stuff to the cache or taking it out. But if you start thinking about specifics of how that logic would look like, so do a lookup in Hazelcast, but if it's not there, then do a lookup for a database. If you found it, put it in a Hazelcast. If you start thinking about extra complexity involved, the fact that these are distributed systems, and you don't have transactional guarantees between them, suddenly it became a bit more difficult. So this setup is probably the most basic one, but quite often you would like to use it in a bit different way. So one of those ideas is read-through. So in this place, these arrows go in a slightly different way. Those are still same boxes, but your application would avoid talking to a database directly. Your application will talk directly to a Hazelcast cluster, and if Hazelcast cluster doesn't have an entry in itself, then its the Hazelcast that's responsible for doing the lookup in a data source and backloading these data directly into the cluster, which makes things way easier because you don't need to integrate between two systems, but with just one. The same would happen the other way around if you have a write-through. So if you don't need to worry about orchestrating writes, dual writes to heterogeneous systems, you can use the write-through. So you write Hazelcast itself, and then it's the Hazelcast who is responsible for flashing this data right to a database synchronously in this case. And you might be thinking, Greg, but I got Hazelcast to make this stuff run faster. But if I'm writing stuff to Hazelcast and then I'm waiting for Hazelcast to write it down to a database, you know, I'm not a PhD, but this is probably be slower than writing direct just to the Hazelcast itself. And you're right, it's a trade-off. If you really care about performance, you can go for the write behind, which means you write data directly to Hazelcast, and the data gets asynchronously flashed to an underlying data source later on. Obviously, that's a trade-off, which means you need to accept certain consequences. But why am I showing you this? If you look at those pictures, you know, it looks easy. You know, it compiles on the PowerPoint, right? Because arrows compile, as you can see. But there is this part over here on the right. You see, there's this mapstore.store. There is this mapstore.store and map-loader-load. It's effectively a piece of Java code that's responsible for reading or storing the data, which you need to pretty much write by yourself to be able to do that. And I believe we managed to get this improved. So once this is already ready, in your architecture, once you are pulling data from a data store, by the way, there are other options to do that as well. For example, by using change data capture. If you have data in your cluster already, there is one low-hanging fruit. So in the past, we've had two products. We've had Hazelcast, IMDG, and Jet, a stream processing tool. The interesting part was that there are two interesting parts here. First things first, Hazelcast Jet would depend on Hazelcast itself. It would use Hazelcast internally to be able to manage its state and metadata. And second interesting part about Jet as a streaming tool is that we implemented Project Loom we as a company, not me, implemented Project Loom way before it was popular. So at the core of it, there is a Loom-like taskpad engine, and it was actually described, and you can read a white paper about that. So we have already in our architecture Hazelcast, and we figured out that there is this Jet product that depends on Hazelcast. So it was kind of a no-brainer to put those products together, because we noticed that our customers, they already have Hazelcast 4. They have a lot of data in there, and a lot of low-hanging fruits, a lot of opportunity to use, which means, and this opportunity could be unlocked if they had access to Jet. So once we merge those products together, forming Hazelcast Platform 5, now all those customers, they get access to the data, and they can pretty much react to this data instantaneously in real time, unlocking interesting business opportunities. So for example, in the past, I implemented a setup for a telecom company, and they were doing something cool. They would analyze how MSISDN numbers would connect to various BTS stations, and they would analyze the patterns. And if there is a pattern, if it looks like that people are moving closer to the border, it's quite likely they are going to cross it. And if going to cross the border, they probably procrastinated and didn't get the roaming packages. So once that pattern was spotted, we could issue a direct offer to that particular customer saying, look, I see you are almost going to cross the border. Perhaps you'd like to buy some roaming, extra internet for your trip. And those are kind of opportunities that streaming kind of enable. And I will let Favas elaborate more on that in the second part of today's evening. So we put those two products together. So Hazelcast is no longer just a cache, it's no longer IMDG. We call it a platform which combines both the IMDG and the stream processing engine, which allows for quite interesting stuff to happen. Because if you have stream processing engine sitting on top of your IMDG, you get pretty much instantaneous enrichment of your streams. So if you're processing data, you can access them directly. The nodes responsible for performing stream processing, they have access to data immediately. And this opens up quite interesting performance opportunities. So Hazelcast is no longer a cache, no longer IMDG. It sits somewhere in between those stream processing engines and in-memory memory stores. So if you now start thinking about IMDG opportunities and stream processing opportunities and opportunities that it gives you when it comes to data that you can ingest, transform, plug some various stuff inside, enrich, and then output, it gets pretty impressive. So we are now trying to position ourselves as real-time enablers. So Hazelcast shouldn't be considered as a key value store, as a commodity that you put only to get lower latency, or you just used because your database wouldn't scale, but a mission-critical system that allows you to your enterprise to make more money. But here's something interesting happened. We had all of that, but the cloud, containers, and Kubernetes revolution came, which changed a bit the rules of the whole game. And so, for example, whenever you wanted to configure Hazelcast itself, normally you would use files for that, XML or YAML files, which is still a good thing to do if you're on production and your configuration is complex. But that would be pretty much annoying if you're starting from scratch and you want to change just a tiny detail. Imagine that you are pulling a Docker container with Hazelcast, but you want to change only the cluster name. And you would need to craft your XML file and pretty much make sure that it's properly mounted and accessible for the container, which is not rocket science, but can be annoying. So also, when I was showing you those write-through, read-through diagrams, that map store needed to be implemented and mapload as well. And that means you need to upload some jar code into the cluster, which again, in the world of cloud and containers and polyglot, can be not that easy, or can be annoying, especially if there's, let's say, a developer coming from a different background, let's say Golang, trying to play with Java. There also, for example, Hazelcast was in the past not designed for auto-scaling, because normally you would just install it on a fixed number of boxes and they would just sit there. But the cloud revolution made it different, because now you can just destroy and create resources on demand whenever you want. And we needed somehow to adapt to that. So we are now in the process of figuring out and providing features that make things as easy as possible to use, not just on-prem, but also in the cloud, in containers, and in Kubernetes in general. And it starts with a very simple and tiny thing. Like, you no longer need to upload your XML files, but if you want to change something in your container, you just provide an env variable that will update the configuration for you. And now something that would take you 20 minutes takes you 20 seconds. Another thing, serialization. If you wanted to have both performance serialization, you would need to upload your own code to Hazelcast. You could rely on the default Java serialization, but that generally has more downside than upside. The convenience being just there's the only upside effectively. So we introduced a new serialization option, which is zero config compact serialization, which doesn't require you to have any classes on the class path of the server. Which means you write your own class, you save it to a map, and based on top of that object, the schema is derived and the data gets stored there. And it's not stored as blob, it has a structure, which means you can do partial deserialization. So if you do server-side compute operations, you don't need to deserialize the whole object each time, but you deserialize only those parts that you really care about, and the rest remains unserialized. So no need to upload jar files anymore, no more, and there is a schema evolution available out there. Another thing that's happening, zero config map loaders and map servers on a roadmap, which means whenever you want to have data ingested into Hazelcast, you will no longer need to upload a jar file having trivial implementation of that, but this will be generic, available for you out of the box. So your only concern is providing the URL and credentials to your data source of your choice, and that would allow you to pull data pretty much instantaneously by a implementation that's available out of the box straight for you. Another thing, all those compute operations that you were able to do with Hazelcast involved some form of Java coding along the way. And if you are a Java developer, okay, good for you, because you can use the same language. If you are not a Java developer, good luck learning Java. So we placed a huge bet on developing the SQL engine. So pretty much all the basic aggregations, filtering, computational side will be available through SQL. I think we can agree that SQL, pretty much everyone out there is fine with writing SQL instead of Java code. So pretty much there's a huge effort to making sure that despite this tool is written in Java, you won't need to interact with Java internals or Java code to make it do the job that you wanted to make it do. However, there's another piece of the story, the auto-scaling. So if you want this stuff to auto-scale, let's say you want to have your own setup in your own cloud, this becomes pretty tricky, because you might be thinking auto-scaling, so you probably need to look on one or two metrics and based on that, trigger your scale up or scale down. But if you start thinking about various types of usages, there's different scaling strategy to be used when you do stream processing. There is different strategy to be used when you do caching. There is different strategy effectively for different usage patterns. So suddenly, developing all of that on your own becomes pretty tricky. This is where our new product comes into place. Our cloud offering, Hazelcast Viridian, which was actually opened up to public literally a couple of days ago. By the way, if you want to sign up and try it out, you can use that QR code. You can sign up with 2 clicks with the GitHub account. And the idea is that to take the Hazelcast and provide something opinionated on top of that. Whenever someone wants to use a cloud service, it needs to be something more than just that product put in the cloud. Okay, I can do it myself. The idea of project Viridian, of Hazelcast Viridian, is to pretty much offload you from all the possible potential worry about the operations of such system. So whenever you try to use it, you get your cluster created within a couple of seconds. You don't need to worry about how many nodes do I pick? What's the ratio between native memory and on-heap memory? How many backups do I want? Do I want those backups to be synchronous or asynchronous? Should I turn persistence on? How do I tune my queues for one replication? All of that concern is out of the way because you're paying only for data and how much you put. The rest is our concern. But building managed service also gives you a lot of opportunities to improve. So, for example, the common problem that I have with cloud services is that they are convenient to run stuff on production, but they are not so convenient for development because nothing beats the good old, embedded Hazelcast, which outputs your logs right to your command line. But with the managed service, we can do quite a lot of tricks. So if you create your account, if you create your cluster, you can download a sample project, That sample project is already pre-configured, and you can connect right away to your cluster. But if you look closely, there's a Maven plugin. And this Maven plugin allows you, even if you need to upload the code to Hazelcast cluster, you can do it right away, right from your command line. You will write Maven package Hazelcast cloud deploy, and your code gets packaged the right it needs to be packaged and uploaded directly to Hazelcast Viridian cloud service. But you get, let's say something went wrong, and you want to debug it. The same command line tool, the plugin, allows you to stream logs in real time based on HTTP server-sent events. So despite this being cloud service, we are trying to make it as comfortable to use as possible. And you can try it out, but keep in mind that this is still in beta. So if you could drop some feedback on our community Slack, that would be highly appreciated. And that's the newest things we've been experimenting with. So that got out, but we are still experimenting with a few crazy projects for the future. So as you know, or probably not, Hazelcast internally is based on the SEED architecture, staged event-driven architecture, which is a very fancy term for just having multiple thread pools being connected by queues. So there's a separate thread pool responsible for taking the network traffic. There's a separate pool responsible for writing to partitions. And it works, but it has downsides as well. For example, it can get tricky to figure out the proper ratio between the thread pool sizes, because it depends on your operating system, depends on the host, it can vary. So we are experimenting with rewriting it to the thread per core idea, where you get on one thread pool only, which has the number of threads which correlates with the number of CPUs, where each thread does its own, the whole job. Anything from taking the reading from the socket to writing to a partition. Thanks to this, you remove all the synchronization, most of it, and if you leverage non-blocking APIs, you are able to fully utilize CPU. And our early experiments and benchmarks showed up like 1 order of magnitude improvements when it comes to throughput. And the best part of that is that it scales really easily, because you always need to have a thread pool of this number of the cores, and that's the optimal setup, regardless of your host. Another crazy ideas we are experimenting with is, for the Viridian itself, for example, creating various smart application profiles. So if you want to use an application that's only stream processing heavy or compute heavy but doesn't store a lot of memory, there's a separate profile, so let's say with tunable knobs that allow you to more or less make it easier for you to set all the settings. Perhaps in the future we could have a UI that would allow, so if we're experimenting with this low-code map loading, map storing, why not take it even further and make it available to log into the cloud service? Let's say I want to have Redis integration or MySQL integration. You click one big button, provide the URL, and the data gets automatically ingested for you. If everything is low-code with SQL, why not have an ability to draw more arrows and boxes and define the pipeline through the UI? So those are kind of crazy ideas we are experimenting with, and I can't guarantee all of them will make it too, but that's pretty much what's on our roadmap. So thank you for listening to me. I hope you learned something new about Hazelcast and in the story. And I highly encourage you to try the Viridian out. We launched it a couple of days ago. Me and developers are extremely hungry for feedback, so we would highly appreciate it. Okay, thank you, and the stage is ready for Favas.